and I am now an assistant professor in Zhejiang University School of Public Health. Today, I'm very glad to be here to talk about my research on the disparity of disparity in heat-related mortality by different types of green and blue space. Um, I should like to give my talk into four parts, including background, methods, results, and conclusions. Um, First, as you know, heat is a significant but still widely underestimated risk. Um, Until now, in each year, there are more than 50,000 excess deaths attributable to high temperatures in the globe. And from this map, we can see China, India, and the European countries are high-risk regions and countries. And in the future, the mortality burden attributable to heat will continue to rise up under the climate change and population aging. And in China, in a high emission scenario, the mortality burden to attributable to heat will be tripled from 2010 to 2019. And the rapid increase of health risks call for an urgent need for more ambitious, effective mitigation and adaptation strategies. And nature-based solutions can help to treat these risks. And green space and blue space, they are often treated as effective and promising nature-based solutions to improve the thermal comfort. Um, the microclimate can be controlled by green space through its shading and evapotranspiration, and blue space can also inform the cool islands through its exchange of air convection due to its higher capacity than other materials on the land surface. In recent years, the protective effects of green and blue spaces on heat-related mortality was reported in several countries and cities. But there were also several studies. They did not support the beneficial associations, including our research in Hong Kong. The potential reasons of the inconsistent results points to the heterogeneity in the landscape composition and configuration across different countries and cities. We know the ability to regulate the temperature of green and blue space varies with its size, shape, connectivity, and the vegetation structure and composition. And such characters largely depend on their types. We know that bigger size, regular shape, and higher canopy of green space, they can produce larger cooling effects. And the second, green and blue space can change the human outdoor activities. This will bring up a question about will the enhanced outdoor activities like walking and sports pose the adverse effects on heat-related mortality. Um, until now, we do not know the combined health effects of various green and blue space types on human outdoor activities and heat exposure. So we conducted our research in Zhejiang province, China. Our study period is from 2009 to 2020. And we can see this population density map in Zhejiang province. We can see the population distribution is very concentrated in low elevated areas. So we use the population weighted temperature to assess the temperature exposure. Then we go to the exposure assessment of green space and blue space. Um, um, if we review the previous research on the health effects of green space, we can see research often use the error average satellite-derived indices, for example, NDVI, to assess the exposure of green space. But this makes it difficult to distinguish different types of green space, and these error level aggregation processes do not consider the population distribution and may cause the big measurement errors of green space. Uh, we can see this called the modifiable error, a real unit problem we call MOP, and the MOP will induce the measurement errors of the green space exposure measurement. So here we developed a green space exposure index based on the green space boundaries and the population distribution data, and we use the buffer zones of the green space exposure to calculate the green space exposure index. We classify the green space exposures into six types of farm, nature reserve, scrub, grass, park, and forest. And because uh, we human often contact with the street greenery, so we also include the street greenery into our types of green space. And we collect more than 3 million street images and use the convolutional neural network model to assess the exposure to street greenery. And we also use the uh, blue space boundaries and population distribution data to construct the blue space exposure index of the overall blue space and the five types specific blue space like lake, river, wetland, reservoir, and coast. And the associations between heat and mortality was explored using a novel case time series study design combined with the distributed lag nonlinear model. And we include more than 3 million cases of deaths. And we first explore the lag response associations between heat and mortality. We can see the lag effects of heat lasts for about 3 days. And we estimated the modification effects of green and blue spaces by adding a linear interaction term with green or blue space exposure index. And then we also estimated the changes of the mortality burden in various green and blue space scenarios. And we also conduct a set of sensitivity analysis. Well, this is our research results. Um, we can see in the left, we can see significant lower heat-related mortality risks um, for the subdistricts at high levels of green space exposure index of overall green space, forest, park, nature reserve, and street greenery. But the effect modifications was not found for grass, farm, and scrub. For example, we can see for overall green space, the relative risks for a subdistrict with a low level and a high level of green space exposure index are 1.18 and 1.13, with a ratio of the relative risk estimated to be 1.05. Okay. And for blue space, we also found the disparities of heat-related mortality risks for overall blue space, lake, and river, but not for reservoir, wetland, and coast. We can see the relative risks for sub-district with a low exposure level and high exposure level to lakes are 1.18 and 1.09, with the ratio of relative risk estimated to be 1.09. We After estimating the effect modifications of green and blue space on heat-related mortality risks, we have also done the simulation of the changes in heat-related mortality burden under different green and blue space scenarios. First, we estimated the overall mortality fractions attributable to high temperature was 2.6%. In the next step, we additionally predict 1.6 to 8.0% in mortality burdens, benefiting from the 10 to 50% increases in overall green space exposure. And we also predict the changes when the green space shrink. For example, 20% decrease in exposure to overall green space was associated with increase in mortality burden by 3.2%. And for blue space, we can see much higher benefits than green space. There will be 5.4 to 26.8% decreases in heat-related mortality burden caused by 10 to 50% increases in overall blue space exposure. The 10 to 50% increases in exposure to rivers are expected to decrease the mortality burden by 1.1 to 5.3%, while the 10 to 50% increases in exposure to lakes are expected to decrease the mortality burden by 2.1 to 10.8%. When the exposure to blue space decrease, we simulated that a 10% decrease in exposure to overall blue space will increase the mortality burden by 5.3%. Okay, just a quick summary of my study. First of all, by this study, we first try to provide direct epidemiological evidence of the effect modifications of different types of green and blue space on heat-related mortality risks. We found the trade-offs between potentially enhanced outdoor activities due to green or blue space and the cooling effects of these green and blue spaces yield net protective effects against temperature related mortality. And we should be cautious that the inequality in exposure to certain types, such as forests, parks, lakes, and rivers of green and blue space, lead to the disparity in heat-related mortality. It informs us to reduce the inequalities in access to green and blue spaces through urban planning and design. And after examining the benefits of the green and blue space, we found that although the protective effects of the green and blue spaces were only moderate, targeted urban design strategies are still encouraged um, for achieving the maximum benefit of green and blue spaces in mitigating the heat health risks and improve other health outcomes. um, and the last conclusion is if the green or blue spaces shrink continuously, other efforts like many heat health action plans to reduce heat health risks will be in vain. Um, thank you so much.
Thank you for the presentation. We will take just one question. Okay.
Yeah, okay. So thank you for your presentation. So I just wanted to quickly ask. So I noticed that you use daily mean temperature.
Yeah.
Yeah. So I was wondering why, because from other studies, probably daily mean temperature is even becoming more important in subtropical environments than the mean of some people who use daily maximum temperature. So I was wondering why you decided to use daily mean as your indicator for temperature?
Thank you for your question. It's a good question, I think. Um, uh, from the epidemiological perspective, we have compared to use the daily mean temperature and daily maximum temperature and daily minimum temperature to conduct our uh, Poisson regression, and we found that the AIC it is criteria of the um, fitting of our regression, they are very quite similar. So for the epidemiological analysis, most research use the daily mean temperature because they both consider the daily maximum temperature and the daily minimum temperature. So we often use the daily mean temperature.
Yeah, actually, I had because the cooling effect of trees. Um, I think it will the use of the indicator would kind of I mean I might be wrong. Like it will alter the pattern of or the strength of the cooling effect that you have shown. So I was thinking maybe that would impact the pulp that you or the trend or the pattern that you've shown in terms of the impact of the of green and blue spaces.
I'm not sure if you mean the trend of the green and blue spaces
And the
change.
trend of the impact of green and blue spaces in reducing the mortality. Now you show that it's kind of moderate. So I was thinking if you change the indicator, maybe that would impact the curve or the impact.
We have compared the two indicators of NDVI and the green space exposure index. We found the similar results for um, the, the, the constrained green space exposure index and population weighted NDVI. So I think um, it could provide evidence that our green space exposure index has the high accuracy and yeah, because if we use NDVI, we cannot distinguish different types of green space.
We can discuss more.
Thank you for your question. I think a few other people had questions, but you could probably directly reach to Kejia because we are running out of time. So we would move to the next presentation.